if you have not watched the elimination video number 1, you need to go back and do so now, because a lot of things are going to be a little confusing, because I'm going to skip right to the good stuff in this one. So, if you haven't done it, go. Bye. I'm assuming that if you're still here, you have watched the first video of solving with elimination, and you're ready for the second one. So, quick reminder, our goal is opposites. So, what's the opposite of 4x? Negative 4x. What's the opposite of negative 5x? Positive 5x. So our goal is to find opposites. Now, sometimes we don't have exact opposites. So that's what's going to make this day, or this video, a little bit trickier. So let's say we had 2x and we had negative 4x. Are they opposites? No. How could you make one of them opposite of the other? Well, what we could do is we could take this 2x and we could multiply it by 2. Then we would have 4x. Are 4x and negative 4x opposites? Yes. So, some of our problems are going to need us to multiply by a number rather than just a negative sign like we did in the other video. So let's go ahead and let's just start tackling some of these, seeing if we can find opposites, because that's what we want to keep in mind. Our goal is always opposites. Looking at this first example, we have it all in standard form, everything's all lined up, but we have x and 4x, we have negative 5y and positive 3y. Neither of them are opposites. So we want to think, how can I make opposites? What's the easiest way to make opposites? In this case, I think the top equation is going to be the one we want to change. I think that we can make opposites for 4x pretty easy. We have 1 and we need to make it the opposite of 4, which is negative 4. We need to multiply this whole equation by negative 4. Now remember, it's an equation, so you have to multiply the whole thing by that number. So it's going to become negative 4x. Now, negative 4 times negative 5 is positive 20y equals negative 28. Now, we don't need that one anymore, so I'm just going to ignore it for a minute, and I'm going to look at the bottom two. This is the system I can solve because I have opposites now. So, if we solve this, 4x and negative 4x, those were the opposites, so they cancel out, they eliminate. I'm left with 23y equals 5 and negative 28, which is negative 23. How convenient! Divide both sides by 23. And we're left with our y value of negative 1. So we're going to write that as an ordered pair, just like before. I'm going to write that in the y spot, and then I'm going to start tackling that x. We need to solve for x. Now we have 3 different equations we can look at, one of the original 2 and our new one. I'm going to pick one of the original 2. Usually that one has the easier plug-in for me. So I'm going to choose this top one. That equation was x minus 5y equals 7. Now I'm going to plug in for y. I know that y is, what do we say, negative 1. So x minus 5 times negative 1 equals 7. X plus 5 equals 7. Subtract 5 from both sides, and we're left with x equals 2. So I'm going to put that down in my ordered pair, and we have our solution. The solution to this system is the point 2, negative 1. So in this problem, we had to make opposites by multiplying one of our equations by not just a negative, but a number this time to make opposites for those x's. Negative 3x, negative 2x. Not opposites. 2y and negative y. Also not opposites. So what we need to do here is make opposites. And we're going to make opposites by multiplying one of the equations, or even 2 of the equations, by numbers. The negative 3 and the negative 2 are probably going to be a little tricky to make opposites of, but the 2 and the negative 1 I can work with. The opposite of 2y is negative 2y. And so if I multiplied that second equation by 2, I would have negative 2. I already have the negative sign that I need. I just need to get a 2 with it. So So we multiply everything by 2, we're going to end up with negative 4x minus 2y equals negative 10. I'm going to rewrite that top equation down so I can see everything together. Negative 3x plus 2y equals 10. I like to do that so I don't get confused. Now I'm going to solve this system by linear combination or elimination. I'm going to eliminate and combine. Negative 4x, negative 3x is negative 7x. Negative 2y and positive 2y is nothing. Negative 10 and 10 is 0. Divide both sides by negative 7. We end up with x equals 0, which is fine. That's cool. Let's put it in our ordered pair. We have lots of ordered pairs where x equals 0. Now we need to find y, and we have a few different options. We can use one of our new equations, or we can use our old one too. Just for fun, let's use one of our old ones. Here we go, that one. It's got negatives and numbers, but we can handle it. Negative 3 times x plus 2y equals 10. But we know x, we know that x is 0. Negative 3 times 0 is 0, plus 2y equals 10. So 2y equals 10. Divide both sides by 2, and we get y equals 5. So the solution to this system is the point 0, 5. Another one where it looks like we don't have any opposites. I would suggest you pause this video right now and try to solve this one on your own first. See if you can make opposites. I am going to do it, but it's a good idea for you to practice it on your own. It's good practice for what you're going to be doing with your project equations coming up soon. Okay, I'm trusting you guys are all coming back after a long pause. 3x and 9x, negative 5y and negative 15y. Neither of them are opposites. I'm going to look at those x's, 9 and 3, because they both are multiples of 3. I bet I can make opposites pretty easily. I have 9x's, the opposite would be negative 9x's. If I have 3, how do I make 3 negative 9? We multiply by negative 3. So I'm going to multiply this whole equation by negative 3. So we get negative 9x, negative times a negative is a positive 15y equals negative 24. Now I do have opposites, so I'm going to combine these two. 9x's minus 9x's is 0. Negative 15y plus 15y, those are also opposites, so they're also 0. Okay, well 12 and negative 24 is negative 12. If we have nothing left on one side of the equation, what do we use to denote nothing? 0 is nothing. So now we're left with the equation 0 equals negative 12. You might remember from some of our other examples, but this is one of our special cases. So you need to ask yourself, when does the number 0 equal the number negative 12? Never. It never equals, 0 never equals negative 12. So the answer is no solution. There's no place where these two lines ever cross. This system has no solution. Remember, the other way you can write that is like a 0 with a slash through it. So this was one of our special cases. We did everything else right. It just happened that these two lines never cross. 5x and 4x, 2y and 3y. Do we have opposites? Nope. Is there a way that you can make 5 and 4 opposites, or 2 and 3 opposites, really easily by maybe just multiplying one of the equations? I can't really think of any. So this is a case where we might have to multiply both of the equations. So we need to think about least common multiples. We can think about the least common multiple between 5 and 4, or we can think about the least common multiple between 2 and 3. I'm going to choose 2 and 3 because they're smaller. The least common multiple between 2 and 3 is 6. So we want to make opposites using 6, and the opposite of 6 is negative 6. So we need one of the equations to have 6y in it, and we need one of the equations to have negative 6y in it. So I'm going to multiply the first equation. I have 2. If we multiply the first equation by -3, we'll end up with -6. Now I'm going to look at the second equation. I think I'll use blue for the second equation. I want to have the opposite of -6, so 6. So I can multiply this one by 2. So the first equation, when we multiply it, we get -15x minus 6y equals 24. And the second equation, if we multiply that, we get 8x plus 6y equals 4. Now we can check. Do we have opposites now? We do. The 6y and the -6y cancel out. So we have -15x plus 8x, which is -7x. We have 24 plus 4, which is 28. Divide both sides by -7. You get x equals -4. So that's the first part of our ordered pair solution. Now we need to find the y. We need to find the second part. We have 4 different equations to choose from, our 2 original and our 2 new ones. I'm going to choose one of the original ones because the numbers are smaller. I'm going to use 4x plus 3y equals 2, but I'm going to substitute what I know. I know x. So 4 times -4 plus 3y equals 2. -16 plus 3y equals 2. Add 16 to both sides. I'm running out of space. I'm going to show you where I'm going to go. I'm going to come over here. So 3y equals 18. Divide both sides by 3 and we get our y value of 6. Put that in our ordered pair and we're done. Our solution is the point -4 and 6. Remember from the previous videos how you can check this is by plugging it back in, both numbers back into the original system of equations. If those equations remain true, then it is the solution to the system. Opposites. We need opposites. We have 4x and -3x, -3y and 8y. I don't see a way that we can make them quickly either, so we're going to have to multiply both equations. Again, this would be a good time to pause your video and try it on your own. So you've all paused now and tried it. We can make opposites with either the x's or the y's. I'm going to choose the x's because those numbers are smaller. We need to think about the least common multiple of 4 and 3. I think it's 12. So we need 12 and we need the opposite of 12, which is -12. If we look at our 2 equations, we already have a negative sign on the bottom one, so I'm going to leave that one as the negative and I'm going to keep the top one as a positive. So to multiply the top one to make positive 12, we need to multiply it by 3. So we get 12x minus 9y equals 75. Now the bottom equation, we need to make the opposite of 12x, which is -12x, and so in this case we need to multiply it by 4. So we get -12x plus 32y equals 40. Alright, so now we can start combining. We have 12x minus 12x, which are opposites, so they're 0. And we have 32y and 9y. Subtract that, and I think you get 23. We have 75 and 40, which is 115. Now we need to divide both sides by 23 so we can get our y alone. So, divide both sides, 115 divided by 23. We have our calculator handy. You grab your phone, pull it out. 115 divided by 23. It's 5. So we have y equals 5. So we can write our answer as an ordered pair. I'm going to write it in the corner with my y as 5. That goes in the second place. Now we need to find x, and we have 4 different equations to choose from. I'm going to choose the top one. I like the top one with 25. I already know y, so I am replacing the y with the number that I know it is. It is 5, so we're going to replace that. Now it's just a matter of solving for x. So 4x minus 15 equals 25. Add 15 to both sides. So you get 4x equals 40. Divide both sides by 4. You get x is 10. So the point 10, 5 is the solution to our system of equations, and we can check it by plugging it back into the original two equations. If you didn't pause for the last one, you should do so for this one. So practice it on your own. Pause the video and try to make opposites on your own. Okay, you've all tried to make opposites on your own. Now, let's see. We have 3x and negative 5y. Oh, uh-oh. Things are kind of mixed up. We need to switch these around before we even try to find opposites. So, really, I'm going to rewrite this system as 3x minus 8y equals 13, and 4x minus 5y equals 6. Now I can start thinking about opposites. And I don't see any opposites, so I'm going to need to think about making them. And again, I'm going to use that 4 and the 3 because those are a lot smaller than 8 and 5. The 4 and 3 have a least common multiple of 12, so I would need 12 and negative 12. I don't have any minus signs to help me out on this one, so I'm going to need to make one of them negative. I'm just going to make the top negative. To make that 3x negative 12, I'm going to multiply by negative 4. Now to make the 4x positive 12x, I'm going to multiply by 3. So my two equations are going to be negative 12x plus 32y equals 4 times 13, negative 40, 52. And on the bottom, we're going to have 12x minus 15y equals 18. So now we have our system ready. We have opposites we can solve. So now our system is all ready to solve because we have opposites. Negative 12x plus 12x is 0. 32y minus 15y is 17y. Negative 52 plus 18, get your calculator out, type, type, type. We're going to get negative 34. Divide both sides by 17. And I made this mistake myself. I had to go back and fix my video. It's negative 34 divided by 17, so the answer is y is negative 2. So I'm going to put a negative 2 where y should go. And then I'm going to look back to my original equations to find x. I'm going to use the top one. It seems the easiest to me. I know y, so I'm going to plug that in. Alright, now we just have to do a little bit of multiplication and we're almost done. So 3x equals a negative times a negative, which is positive 16. Subtract 16 from both sides. You get 3x equals negative 3. Divide both sides by 3, and you get x is negative 1, which is 100 times better than what I got when I accidentally forgot my negative. So there's a good example for why checking your answers is important. You have to make sure you actually did it right and didn't make a careless mistake. This is the exact same list of steps for solving as on the other elimination video, but just to remind ourselves, we want to get our equations lined up in standard form first. That wasn't the case with one of our examples in this video, so it is important to keep that in mind. Then we need to look for opposites. If we don't have opposites, we get them by multiplying. Sometimes it's just one equation, sometimes it's both equations. Next, you combine your two equations to eliminate a variable. You solve for the variable that's left over. After that, you plug it in to one of the original equations or one of your new equations to find the value of the remaining variable. And when you're all done, you write your solution as an ordered pair. There's my typo again. And you always need to remember to check it because sometimes that xy that you think is right, it's not right. If you check it, you need to make sure it makes both equations true. solving systems with elimination. We did the trickiest ones already. You should be good to go.